Hello everyone. So far we have developed with the help of integration, how do we find area under the curve, and it defines for us integration approach. This is something which we have already done. Now how we can take help of this graphical approach for integration in Newton's equations of motion is something which we'll learn in today's class. We have already developed first method for Newton's equations, that was with the help of calculus, that is differentiation and integration. In second approach also we are using the same thing but graphical representation. But before that, there are few things which you need to know, and this is called coordinate geometry. We'll discuss little bit coordinate geometry here, and then with the help of this and the graphical approach for differentiation and integration, we will ultimately develop Newton's equations. So write down the heading coordinate geometry. And just don't worry if you think it's maths and you're not comfortable with this type of thing from 9th and 10th. Just don't worry, basic fundamental things will be clear in this lecture only. In coordinate geometry, everybody knows these things. This is x-axis, this is y-axis. If you take a point, its coordinates are x comma y. X comma y means, for example, 2 comma 3, and this 2 comma 3 means this height is 3, it represents y coordinate. This distance from origin, it gives you what? X coordinate. This is the only thing in coordinate geometry which you need to know as of now, and I hope everybody knows this. Distance from the origin is your x coordinate, this is your y coordinate, this will be called x coordinate, this will be called y coordinate. Now the thing we are interested in is equation of a straight line. Write down another heading, which is equation of a straight line. What is the meaning of equation? It will be clear. Write down the heading equation of a straight line. Draw this elementary figure as a side node. Now the equation of a straight line will develop two cases. First is when line passes from origin. Write down this first case, a line passing from origin. We need equation of that line which passes from the origin. What is this? Now pay attention to this figure. We have the axis system as usual, and we have a line, and the line is this. This is a straight line and it passes from origin. Everybody knows this point is what? Origin. I hope you can see this thing. This line, we have been told, makes an angle theta. This angle theta is between the line and the x-axis. This is something which we know. And everybody knows that tan of theta is perpendicular upon base. What is this? Look here. Suppose we have a point on this line and its coordinates are x, y. This is the line. There is a point on this line. Its coordinates are x, y. If I ask you what is the relation between x and y coordinates, then that relation is called equation. If you can represent y in terms of x, then this is called equation. Any point which lies on the line, say, is represented by x, y. From this you know the height is nothing but y coordinate, and this base is your x coordinate. It's a right angle triangle. In this right angle triangle, if I need tan of theta, then what is tan of theta? Perpendicular y, base x. We'll write this as y upon x. This tan theta in coordinate geometry is given a special name, symbol. The symbol is what? M, is y upon x, but from differentiation you already know that tan of theta, it was given a name, it was slope. So this M is also called slope of the line. Now listen again. What is tan theta? Perpendicular upon base. This tan theta in short is represented by M. This tan theta, I told you in differentiation when we developed slope of a tangent. What was tangent? Tangent was a line. What was slope? Slope was tan of theta. So this M, which is tan theta, is called slope of the line. And once I do this, this y and this x, they are related like this. Y is equal to m into x. Y is equal to m into x, which is nothing but y is tan of theta multiplied by x. This y equals to mx, it does what? It relates x coordinate with y coordinate and is called equation of a line which passes from origin. Note on this much, and all the meaning of y equals to mx, coordinates, point, this thing will be clear once we take few examples. At this stage, if you think you're a little bit confused or you have no idea what is going on, just don't worry. Within few minutes, everything will be clear. Note down everything written on the board. Well, one person is saying that video is blurred. Is it with everyone? Everybody finds that video is blurred? Yes or no? Okay. People are saying no, people are saying a little blurred. Let's do one thing. Those of you who find that video is blurred, just disconnect and reconnect again. And I will also do the same. I hope things are better now. Write down a statement. Equation of a line, equation of a straight line that passes from origin is y equals to mx where m is called slope of line and this slope is nothing but tan of theta. This slope is nothing but tan of theta, where theta is angle between the line. Theta is angle between the line and horizontal axis. theta is angle between the line and the horizontal axis and should be taken from the positive side anti-clockwise. Should be taken from the positive side of horizontal axis. Should be taken from the positive side of horizontal axis anti-clockwise. While developing slope of tangent in differentiation, we have already done this thing, so it's not something which is entirely new. Whenever you will go for theta, it should be taken from this side anti-clockwise. Now, write down the next line, which is basically the fundamental thing, but in case you forgot the whole meaning of equation, it will help you. When we say equation of a curve, when we say equation of a curve means anything which you can plot. You can plot a line, you can plot a circle, you can plot a parabola. What is a parabola? We'll see it later. So all these things are called what? Curve. Curve. Even a line is a curve, but this curve has a special name which is called what? Straight line. This curve has a special name which is called circle. This curve has a special name which is called parabola. So when I say equation of a curve, complete the sentence. Equation of a curve means relationship between x and y coordinates. Equation of a curve means relationship between x and y coordinates. Now, let's understand meaning of equation with the help of elementary examples. And as I told you, if you are still confused slightly, just don't worry. Look here. We were told that there is a line which passes from origin and it makes an angle of 45 degrees. This angle is 45. This is your x-axis, this is your y-axis, this is the line. Now, forget about this equation. You have no idea what this equation is. I simply told you that this angle is 45 degrees. Tell me this. If I take a point on this line and I tell you that this point, its x coordinate is 1. This point which lies on the line, its x coordinate is 1, and I ask you what is its y coordinate. Then in just 1 second write down the answer. What should be the y coordinate of this point if x coordinate is 1? The angle is 45 degrees. Good. Everybody can see that when you say x coordinate is 1, basically we can draw a right angle triangle. I hope you can see it. We can draw a right angle triangle. In this right angle triangle, question says base is 1. This angle is 45. If it's 45, this is 90. You know that this angle is also 45. That makes it an isosceles triangle. If it's an isosceles triangle, then these two must be same. Let me repeat it again. This is 45. This is 90. This is 90. Therefore, this angle is also what? 45. If you say this angle is also 45 degrees, it becomes what? Two angles are same. It's an isosceles triangle, and therefore these two arms must be same, and you would have said y coordinate should also be 1. Now again, if I take another point and I say that its x coordinate is 2, then I hope you understand its y coordinate will also be 2. Why? Because if you draw another right angle triangle, base is 2, this angle is 45, and therefore the other coordinate should be 2 only. So what you have observed so far? You have observed one thing. If you take a line which passes from origin and makes an angle of 45 degrees, then x and y coordinates, they are always same. This statement is called equation of a line. On this line, every point has x and y coordinates which are always same. In terms of maths, you say this. What is the equation of a line? Y equals to mx. What is m? M is tan of theta. What is theta? 45 degrees. What is tan 45? 1. So math says, what is the equation of a line that passes from origin? Y equals to mx. That is 1 into x, which is y equals to x. Directly with the help of this, you arrive at y equals to x. You don't have to draw these triangles again and again. It saves you time. This is nothing but equation of a straight line. If you understand meaning of equation and all these things, then write down yes in the comment box. a line makes an angle of 60 degrees. Write down equation of this line in the comment box. A line makes an angle of 60 degrees with x-axis. Write down its equation. Good. What is the equation? Y equals to m. What is m? 10 of 60. So what is the equation of this line? Y equals to root 3x. What does it mean? It means this. If somebody takes a point with x coordinate 1, you don't have to draw any right angle triangle. Immediately you can say its y coordinate will be root 3. So this equation tells us this information. If you have a point whose x coordinate is 2, multiply 2 with root 3 and you will get the y coordinate 2 root 3. Any point on this line has to follow this relation, which is called equation. This is y-axis, this is x-axis. Now, look here. It's not about y and x. It's about anything which is on the vertical axis or is on the horizontal axis. So if I give you a graph between velocity and time, and this graph is in the shape of a line, straight line, and this line makes an angle of 37 degrees. I hope you remember 37. Then write down equation of this line in the comment box. Let's see how active you are. Do one thing first, write down the question. A graph is plotted between velocity and time. A graph is plotted between velocity and time and is in the form of a straight line and is in the form of a straight line which makes an angle of 37 degrees. The graph is plotted between velocity and time and is in the form of a straight line which makes an angle of 37 degrees with the time axis Then find out equation of this line. That is relationship between velocity and time. That is relationship between velocity and time. And in case you don't remember what 37 is, for those who don't remember this, if you draw a right angle triangle of 3, 4, 5, these side lengths, then this angle is 37. This thing gives you tan 37 as 3/4. Now let's see how many of you can solve it. Almost everyone has done this. Some of you have committed a silly mistake. What I say, graph is between V and T. So do one thing. You have replaced Y with V and you have replaced X with T. You can also show with different color if you wish. So the equation which was y equals to mx, in physics it will take this form. Your y becomes v, m is m, x is what? T. This is the equation of this line. And what is m? Tan of 37. What is tan 37? 3/4. If time is known, with the help of this, we can get value of v. This is the advantage of developing these equations. Note down this much. Now, let's develop second case. In first case, line was passing from the origin. What if line doesn't pass from the origin? So this becomes your second case. Write down second case. Equation of a line which makes an angle of theta with x-axis, When I say x-axis, it means horizontal axis. It can be time, it can be any axis. Do one thing which makes an angle of theta with x-axis. After this, inside the bracket, write down horizontal axis. equation of a line which makes an angle of theta from the x-axis inside the bracket, horizontal axis, and look here, this portion which you see is called C, is called intercept. Intercept cut by the line on y-axis. Or basically this is between origin and this point. This length has a name and it is what? C. This is called what? Intercept. Write down the complete part. C is intercept cut by the line on y-axis. So now we have two information. One is line, it makes an angle of theta which gives us m, tan of theta. And second information is the intercept which is C. Let's see how active you are. What should be the value of C so that case 2 becomes case 1? Mention in the comment box. What should be the value of C so that case 2 it becomes case 1? Good. If C is 0, then this line, it will pass from the origin. The case 1 is nothing but a special case of the second situation. So once we develop the equation, and if we put C equals to 0 in that equation, you will get your case 1 only. We'll see that. Now, let's use this information and find a relationship between y and x. Look over here. Nobody will ask you these proofs, but if you understand how do we arrive at these elementary things, then you will find that physics is quite interesting. So the information is we have a line. This is the line. If I take a point with coordinates x and y, remember this is theta. Remember this much, this highlighted portion is C. This point is x comma y. Equation means relation. We'll do what? We'll construct a right angle triangle. This height, everybody knows is what? Y. If this height is y, then this base is x. This is y, this is x. But if you look at this figure, it doesn't complete a triangle. But if I can do this, if I shift my base over here, if this is x, then everyone can see that this is also x. If I say this is 2, then this is also 2. Now tell me this. Look here and you will answer it. What about this length? How much is this length in red? Write down this length in the red in the comment box. Length in blue it is y. Length in blue which you see is your y coordinate. It gives you y distance. I hope you can see it. And I'm asking you, what is the red portion? Good. This is y. But look at the intercept C. This is y, this is C. The length in red, this length in red is y minus C. And everyone can see this is still theta. You've got two parallel lines and therefore this angle is what? Theta. And you ultimately arrive at this figure. We have a red color triangle. Red I am just using so that you can distinguish easily. We have a triangle like this. This angle is theta. This length is y minus c. This length is x. You've got 10 seconds, 30 seconds. Write down equation of this line. Let's see how many of you can complete this article on their own. Find me the equation of line using this red triangle. Good. For this, tan of theta perpendicular divided by base, but tan theta in short is called m, which gives us y minus c equals to mx, which gives us y equals to mx plus c. This is equation of any line whatsoever. It can pass from origin, it cannot pass from origin, doesn't matter. This is the equation of a straight line in very general form. If somebody tells you that he is interested in case 1, line is passing from the origin, replace c with 0. Once you say c is 0, your equation is what? Y equals to mx. If you understand case 2, then write down yes in the comment box. And if you have any doubt, just mention your doubt. Write down the statement. If line passes from origin, then C becomes 0 and we arrive at first case. Second point. If intercept is above the horizontal axis, then it should be taken positive. But if it is below the horizontal axis, then should be taken negative. This is line 1, this is line 2. They both are making an angle of 45 degrees. 45. This intercept is 5. This intercept is also 5. Take equal lengths. The intercept is 5, intercept is 5. Write down equation of L1 and write down equation of L2 in the comment box. L1 first line, L2 second line. For both lines, write down the equation in the comment box. Length of intercept is 5. But when you will write the equation, you will use correct sign. Don't write m, you have the value of m. Simplify it, write down the value of m. For L1, y, m is 1, 45, tan 45, 1, x plus c, 5. Done. L2, y, m. For second line also, it's 45. C, what is the intercept? On the negative side, minus 5. So this is your L1 and this is your L2. That's how we can develop these equations. Answer this. This is the line. This is 2 and this angle is 45 degrees. Write down equation of this line. Let's see who can answer this. Everyone should give it a try. Well, so far only one answer is correct. Now is the second answer correct. Only two have produced correct values. And the hint is slope is not tan 45. This is the hint. This is the hint that slope is not tan 45. So what most of you have done, you have taken C as 2, which is correct, but you have taken M as tan of 45, 1, which is not. How did I define theta for slope? I told you that theta is taken from the positive side anti-clockwise. This is your theta. From the positive side anti-clockwise. What is this angle? This angle is what? 135 degrees. I hope you understand this. 180 minus 45. And therefore, M is tan of 135 degrees. That's your M. But now we need what? Tan of 135. And we have already done things like this. Tan of 90 plus theta. Not this theta, it's a formula. What is tan of 90 plus theta? Remember, minus of cot theta. I hope everybody has seen the lecture on trigonometry. I had sent you a lecture, first lecture on trigonometry, and then I sent a second lecture. I hope everybody has seen both those lectures. If somebody for any reason has not seen those lectures, just send a request and you will get those things. But right now, remember this formula. It's a special formula. Tan of 90 plus theta is minus cot theta. It has nothing to do with this theta. If you have any angle over here, find cot of that angle, put a negative sign. Which is what this. If somebody says find out tan of 135, we'll write it as tan of 90 plus 45 degrees, which is minus of cot 45, and you know what cot 45 is, minus of 1. So your tan 135 is coming what? Minus 1. Now, if you remember the shortcut, what was the shortcut? And remember this shortcut always. If they ask you, forget the shortcut part. If they ask you tan of 135 in this form, instead go for tan of 45 degrees. What I am doing is this. If they ask you tan of 135, tan of the obtuse angle, then find tan of this side, 45, and put a negative sign. It will save you a lot of time. We have done this thing again in differentiation, graphical representation. What is tan 135? Forget about it. Go for tan 45. Use a negative sign and you get -1. Same result. So, once you say m is -1, equation is what? Equation is -1x plus intercept 2. That's the equation. Note down this and answer this. We have a line and this line makes an angle of 37 degrees like this, and this intercept is 2. Y, x. Write down equation of this line in the comment box. Fast. You don't have to use any tan 90 plus theta or things like that. It should be answered in just 5 seconds. Should not take more than this. You don't have to worry about all these information. So technically m is tan of 37. No, m is tan of basically this 180 minus 37. We need this angle. This is 180 minus 37. And I told you that you don't have to worry about this. We need this, but we'll go for this angle. Tan of 37 and just put a negative sign. So if you need tan of an obtuse angle, this is an obtuse angle, go for the acute one and put a negative sign. Remember this trick. If you need tan of an obtuse angle, go for the acute one and put a negative sign. What is tan 37? 3 by 4. Your intercept is not 2. It is minus of 2, which gives you your equation as y equals to m plus c, which is minus 2. This is the equation. Now those of you who could not develop this equation but they understand it, those of you who attempted this thing but got a wrong result but now they understand the whole thing, they also should write yes in the comment box. And if you are confused, if you have any doubt, just mention your doubts. Now let's use all this information in physics. You know the aim. We need to develop Newton's equations. Write down the conditions which were used. What are the two conditions which are required if one has to use Newton's equations? Let's see how many of you remember those conditions. When we developed Newton's equations with the help of first method, I had told you that these equations are used only if so what is only if? There were two requirements. First was acceleration should be constant. And second is motion or path is one dimensional. These are the requirements for Newton's equations. Acceleration should be constant, path should be one dimensional. Now, I'll ask you a second statement, second thing. If a graph is plotted between velocity and time, let's see how many of you remember this. If a graph is plotted between velocity and time, then slope of tangent represents what? Write down this in the comment box. Well, that's what I thought you will answer. Most of you are answering displacement because we just finished what? Area under the curve. But you are wrong. Some of you answered correctly. If you draw a graph between velocity and time, its area under the curve, that gives you displacement. But I have asked you slope of tangent, and that was differentiation, that is acceleration. Write down this. If a graph is plotted between velocity and time, if a graph is plotted between velocity and time, then slope of tangent represents this is your tangent. Slope of tangent represents acceleration. This is your graph. This is the tangent. Slope of tangent. What is slope of tangent? Tan theta. Slope of tangent is what? Tan theta. What is tan theta? dv upon dt. d whatever is on the vertical axis divided by d, whatever is on the horizontal axis. And what is dv by dt? dv by dt is what? A, acceleration. So we have already done this thing, nothing special. If a graph is plotted between v and t, slope of tangent gives us what? Acceleration. Now I hope all those who answered displacement, they understand this part. Now, and therefore don't forget to write down this thing as a side note. But now let's complete this part. If I say that a graph is plotted between v and t, look here, if a graph is plotted between v and t, then tell me for Newton's equations, which means what? Acceleration constant, can we have a graph like this? What do you think? Yes or no? Write down in the comment box fast. For Newton's equations, can we expect a graph like this? What do you think? Yes or no? Good. No. Why no? If I draw a tangent at this point, say this angle is coming 30. So if I draw a tangent at this point and the angle is 30, if I draw a tangent over here and the angle is coming what? 60, you can see that at this time your slope is changing, your acceleration therefore is changing, but for Newton's equation acceleration must be constant, and therefore a graph like this is not possible for Newton's equations. Draw the graph and write down the statement. A graph given in the figure is not possible for Newton's equations as slope of tangent is continuously changing. Slope of tangent is continuously changing. That is, acceleration is continuously changing. That is, acceleration is continuously changing, which is not possible for Newton's equations. So this graph is something which is not correct for this. Now tell me this. What shape should a graph have for Newton's equations? If you have any idea, mention it in the comment box. What do you think should be the shape of the graph if somebody plans to draw it for Newton's equations? What type of a graph you must have so that everywhere you go you find same type of slope? Good. it should be a straight line. And that's the reason we developed coordinate geometry in today's lecture. If I draw a graph like this, well, I'm not taking it this side now because, or you can draw it like this if you wish. You'll always find something like this because this is now what? Time. Right here t is what? 0. On this side t is negative. But time cannot be negative and therefore we are not drawing this side. So graph is this, which is nothing but a straight line. For this straight line, anywhere you go, if I draw a tangent at this point, then you know that for a straight line, tangent is the line itself. Or I can show it with the help of this blue colored. Remember, they are touching. This blue is touching the black, if you can see it. Just so that you can feel it, I have created a bit of separation between them. So the black, in black you can see the graph and in blue you can see the tangent. Which means for Newton's equation, if you draw this tangent at this point, at this point, at this point, everywhere theta is coming same. Write down the statement. For Newton's equations, as acceleration is constant, as acceleration is always constant, graph between velocity and time should be a straight line. Graph between velocity and time should be a straight line. I'll take 5 minutes more and therefore have patience. Graph between velocity and time should be a straight line. Now, last 5 minutes, look here. This is V, this is T, and we have a graph like this. This is theta. This is theta. What is tan of theta? What is tan of theta? Tan of theta is called what? dV by dt. Pay attention to this. What is tan theta? Tan theta is slope of tangent, which is d by dt, which is a. But tan of theta for a straight line has a name, and that name is what? M. I think things are clear. This is the line. This line itself is a tangent. Line itself is a tangent. For a tangent, tan theta is d vertical axis divided by d horizontal axis, which is a. For a line, tan theta has a name which is called m. Now, what is this time? You know that this time is t equals to 0. What is this value? Look here. This is velocity axis. Vertical axis is giving you what? V. At t equals to 0, which is the origin. Origin means now t equals to 0. At t equals to 0, whatever is written here will give you what? Velocity. But at t equals to 0, velocity has a special name. And what is that name? U. U means what? Initial velocity. So at t equals to 0, what is written here? U. Whatever is written here, it means what? This much length. Suppose it's written 8 over here. Then it means what? This length is 8. If it's 15, if u is 15, then you will say that this length is what? 15. But equation of a line says that this thing has a name, and that name is what? C. So what is C? U. Which means, what is the equation of this line? Equation of this line is what? V equals to mt plus c. It's coming from what? Y equals to mx plus c. X was the horizontal axis, which is t. Y is the vertical axis, which is v. So this line, its equation should be v equals to mt plus c. What is m? A. What is c? U. This is the first equation, v equals to u plus at, with the help of coordinate geometry, slope of a graph with the help of differentiation. These two things and you get this equation. If you understand this much completely, then write down yes in the comment box and then you can leave. And if you are confused, you can simply ask any question.